Hello. Today we'll talk about the derivative of x square and x cube. Okay, so how we can interpret it geometrically. So the geometrical way will be something like this. If I have a square of area x square, okay, this is a square of area x square, and if I extend this, if I extend this square a little bit, okay, so if I can I not select the so if I extend the square a bit, now this is our original square, okay, this is our original square. Let's make another border to our original square so we can classify it. Okay, just a minute. So yeah, we'll continue. If we what the topic was, if we extend the square a bit, so if we extend the square a bit, we would have three parts. Okay, the first one is this rectangular part, right? Right, this part right over here. So we would have this part, okay, which I will keep here, plus the uh second rectangle which we have over here. This is the second rectangle, right? So this is the second rectangle. So this plus a small square right in the corner, right? In the right corner we have the small square which is our next uh okay, it's so small, we'll just erase it. Okay, so it's it. Okay, so this square right over here, I will also add that. Okay, and one more thing, the change in the area is caused by a small value, that is dx, right? So this area, this side is dx, this is also dx, okay, this is also dx, so this is also dx, while this part is x, right, because as it's the original part, so this part is x. Similarly, this part over here is also x, right? So rather than here, I can just mention it over here. So this part which you see is x, and the other small part is dx. So we'll just see. It will be the area of the first rectangle, that is x dx, plus the area of second rectangle, that is x dx again, plus the area of the square, that is dx square, right? And now here we can take dx as common. So dx x plus dx square, and then it will be 2x dx plus dx square. I hope you are understanding, right? And when you talk about the small part, the area of the small square, that is dx, okay, when you talk about this, it is safe to ignore this dx square, right? I will just write it. It's safe to ignore in calculus because it's a very tiny tiny area, right? For the sake of demonstration, I am showing this dx a bit bigger, but while solving problems, you consider this dx as very tiny square. Here it is very big, right? When we talk about calculus, this dx, the amount of dx I had taken is very big. can imagine it as a very, very small value. So it is and when we are squaring it, it becomes small again. So it is safe to ignore such a small value, right? It's a very, very tiny value. Very, very tiny value. But for the sake of explanation, I have shown bigger, right? Very, very tiny value or very, very small value, right? So now what we are left with is df, that is a change in area, that is a change in the function, that is, and when you say change in function, the function here actually is x square. So f is equal to x square, and the change in area, that is df is 2x dx, right? The change in area is 2x dx. And when you take this dx on the other hand, you will get df by dx is equal to 2x, and this is how you derive the derivative of x square. So when you are given a function of that is x square, this is its derivative. And now you know how it came. You are not just by hearting that d by dx square by dx is equal to 2x. No, now you know how it came, right? So basically, if I have to summarize it in a shell, the change in area in this square is caused by dx, right? Is caused by dx, and then you are adding those all the areas, and then you get this, and you are ignoring this dx square. So by ignoring it, you get df is equal to 2x dx. So here it is also df. So everywhere it is df, right? here it is the same. So here it is also df. So df is equal to 2x dx plus dx square, and then you are ignoring it, and you are left with this, right? df is equal to 2x dx. And when you take the dx on the other hand, it becomes df by dx is equal to 2x. And now we know how it came. So yeah, that's all for the video, guys. I will meet you in the next interesting video. Till then, keep learning. Bye bye.